is day-to-day performance. You all of you know that in autonomous structure there is a marks given to the day-to-day performance, so definitely it will be affected. So keep in mind that, all of you. Okay, so I would like to share the presentation. Okay, so are you able to see the presentation? Yes, no?
Yes, sir.
Okay, so just I have revised here what we see in last lecture. So if you see we want to see the homoatomic polymers containing phosphorus, and the allotropes of phosphorus is white phosphorus, red phosphorus, puckered layer of black phosphorus, and there are some examples like phosphorus dihydride, then phosphorus dihalide, as well as hypophosphoric acid. Okay, so in case of these phosphorus, that is polyphosphines such as phosphorobenzene and phosphor trifluoromethane, they are thermally stable, and their thermal stability can be explained on the strong bond between phosphorus and phosphorus. Okay, so when the bond formed between phosphorus and phosphorus, among that the strength of pi bond, phosphorus phosphorus bond, is due to why? It is because of the pi bonding effect. Uh, that is lone pair of electrons on the phosphorus atoms, and EMT 3D orbitals on adjacent phosphorus involved in pi bonding, and that's why you see here in phosphorobenzene and phosphor trifluoromethane there is a one is the sigma bond, another one is the pi bond, and that's why this molecule is a stable one. Okay, so next we see the fluorocarbon, and in case of fluorocarbon we see that it is actual organic polymer. But what happened? Organic hydrocarbons in which only the hydrogen atoms are replaced by the fluorine molecule, and that's why we sometimes it is called as a organic polymer, because in case of change the carbon hydrogen, in that case there is only change, that is carbon fluorine, but carbon is in their backbone along with fluorine. That's why we say that is an organic polymer. But due to their outstanding properties, means without hydrocarbon, the carbon and fluorine both combined together form these different properties, and that's why it comes under the heading of what? Inorganic homoatomic polymers. Okay, why it is called as homoatomic polymers? Because there is a fluorine. Okay, and that fluorine attached to the carbon, but actually it is in the case of what? Heteroatomic polymer, but due to the significant property of fluorine, that comes under the heading of what? Homoatomic polymer, because without carbon, the fluorine having the significant role to maintain their properties and structure in this case of polymer, and that's why it is what? Homoatomic polymer. So in the case of preparation, you should know that when carbon monofluoride is the simplest polymer, and it is prepared by graphite at 420 degrees Celsius to 460 degrees Celsius in a steam of fluorine. It is solid having different colors from gray to white depending upon its fluorine content. Okay, and in this way the fluorocarbons are formed, and we also seen that due to chlorofluorocarbons that directly reacts with what? Ozone in static fluorine, and there is a cause of ozone hole. So everybody know that what is the cause of ozone hole? The main cause of ozone hole is what? Chlorofluorocarbons. Okay, further they are heated to get useful monomer, that is C2F4. Okay, so when chlorofluorocarbon heated at 600 to 800 degrees Celsius, then there is a useful product is formed, that is C2F4. Next one, the polymerization is carried out in radical initiator, and that radical initiator is what? Sulfur containing compound that is potassium sulfoxide, K2S2O8, and there is a polymer form. It is sold under the trade name Teflon. Also, fluoro aromatic polymer can be synthesized. So all of you know that the Teflon is a very stable form of the element, and it is widely used in the process of sealing of the reaction, making the magnetic stirrer, that all from made up from what, this Teflon, and this Teflon is prepared by such a chloro, that's fluoro aromatic polymer. Okay, so that part we have seen in last lecture. Yes. Now today, what we want to see, we want to see the properties of what, uh, this fluorocarbon polymer. Then what is the properties? If you see the material with 68% of fluorine, that is the less percentage of fluorine, then its color is what? It is a gray. While material which containing 99.5% of fluorine, then it is white in color. So most pure form of this fluorocarbons is what? It is a white form. It is about 99.5% pure, while 68% of fluorine showing the gray-like structure. It is not white. Okay. So the others may have color between gray and white. Okay. If you take examples of other phosphorus, that is 80%, 85%, 90%, 95%. So when less percentage of phosphorus is there, then it appears as a gray color, while the higher percentage of fluorine is there, then it appears as a white in color. Okay, so as the percentage of fluorine going to increases, the polymer becomes what? White and white color. If the fluorine percentage goes on decreasing, then it appears as a gray color. Okay, so this is the most significant property of what? Fluorocarbons. Then the electrical conductivity. So you see the electrical conductivity decreases with increasing the fluorine content and nearly zero for white material. So this is upon the distinguished and very important point related to the electrical behavior of the fluorocarbons. So what is that? The pure form of the fluorocarbon, it means the percentage is above 99%, then it does not show the electrical conductivity. But if the gray form, that is the less of fluorine content is very less, then it acts as a electrical conductivity. And that's why electrical conductivity decreases with increasing the percentage of fluorine, and the white, that's fluorocarbon, is does not carry the electrical conductivity. Okay, all of you understand? Yes or no? Hello? Anybody give reply? Do
Yes,
you
sir.
understand? Okay. Now we see that this inorganic polymer is more less effective when it employed towards what? Acid alkalis, and due to that, this fluorocarbon, it is not attacked even by concentrated acid and alkalis, and is also not weighted by water. Okay, even though when water is fall on it, it does not get weighted, and that's why the stability of this inorganic polymer is very high as compared with the other polymers. Okay, why? Because it is does not attacked by concentrated acid and alkalis, and is also not weighted by water. So what are the uses of this kind of polymer? So if you see, the it cannot affect by the acid, alkalis, and not weighted by water, and due to that it having significant application. Okay, what is that? You see, due to their outstanding properties, they are used as lubricants. Okay, so they are used as a lubricant, then adhesive, coatings, bearings, gaskets, non-sticking cooking appliances. So everybody very familiar with the non-sticking cooking appliances, because that we use day to day life. Gaskets, you know that all gaskets cars, that is uh, that Wagoner and many more petrol having cars, that cars having the gaskets. So these gaskets are also made by these fluorocarbons, then bearings, then coatings, adhesive, and it is used as lubricant. Okay, so their elastic material are used in aircraft industries. So whatever elastic material of these fluorocarbons that are used in aircrafts, okay, in aircraft industries, and you understand that what is the major application of these fluorocarbons in case of all type of industries, and most important is the aircraft industries require such type of polymer to making the good quality of aeroplanes. Okay, all of you understand? Yes or no? Yes or no?
Yes, sir.
Okay, so next, what do we want to see? So next part is a structure of that polymer, and if we see the structure of mono, no, that is carbon monofluoride. Okay, so I am giving here the structure. You see that. Are you able to see the PPT? Yes or no?
No, sir.
Okay, just wait. Right now, you see the structure.
Yes, sir.
Okay, if you see here the structure of what? Carbon, carbon monofluoride, monofluoride. Okay, so what you see here, the layer. Okay, layered structure is there, and in this layered structure, if you see here is the carbon and here is the fluorine. Okay, so the structure of this carbon monofluoride is made up of puckered layers. Okay, that is the structure of carbon monofluoride is made up of puckered. Okay. So that puckered structure we also see in case of what? Which one? Anybody? Yes. You remember or not? In which polymer we see the puckered structure? This one. This is what? What is this? Anybody? Are you listening or not? Hello? Anybody give response, please? What type of the structure? Hello? So 61 students are present and no anybody give the answer. Mayur, Mayur Jagtap,
Yes, sir.
what is this structure? Puckered layer structure
Puckered
of
layer of
what?
black.
Black phosphorus. Okay. So such type of compound structure we seen in what? Carbon monofluoride. It is a puckered layer structure. Okay. So what we see, we want to see some points regarding that structure. Okay. So first point is what? The distance between interlayer. So inter means what? In between these two layers. Interlayer is about 6.6 and strong in it. 6.6 and strong in it. Okay. So this which is which is larger, this is larger than that of graphite. So all of you know the structure of graphite. In that graphite, there is a layered structure, and this layer is puckered in case of the both black phosphorus as well as in carbon monofluoride. So the distance between interlayer is about 6.6 angstrom, which is larger than that of graphite. So this is the point about the structure, and it may be because of fluorine substitution. Okay, so why the distance between interlayer is more in carbon monofluoride than graphite? Because such type of question is asked in the examination. Why interlayer distance is more in monofluoride, carbon monofluoride than graphite? तर काय असेल तुमचा आन्सर? This is due to काय असेल? Anybody? मयूर, सिंपल आहे, स्ट्रक्चर तुमच्या समोर आहे. ओके, ग्राफाइट स्ट्रक्चर माहित आहे का सगळ्यांना? येस और नो? हॅलो, एव्हरीबडी सीन? सगळ्यांना दिसते का स्ट्रक्चर?
Yes, sir.
ते स्ट्रक्चर कशाचं आहे? ग्राफाइनचं आहे. तर ग्राफाइन मध्ये सुद्धा ह्या कशा आहेत? इंटरलेयर आहेत. ओके, आणि फ्लोरोकार्बन्स मध्ये सुद्धा काय आहे? इंटरलेयर आहेत. त्या ज्या काही लेयर आहेत, इथं हे कार्बन मॉलिक्युल्स आहेत आणि जे हॅलो आहेत ते काय? फ्लोरीन मॉलिक्युल्स आहेत. तर हे कशामुळे असू शकतं? म्हणजे प्रश्न तुम्हाला समजला का? हॅलो, डिड यू अंडरस्टँड द क्वेश्चन? Did you understand the question? Yes or no? Hello?
Yes, sir.
So give the answer na. If you don't know, then you say, sir, I don't know. Because what happened, you know that. It is not my duty to just take only lecture, but it's my duty, and teaching is the two-way communication tool. It is not only from my side. Just I am preparing the PPT, showing to you, and that's it. But nowadays it is very important to understand the concept. So bro, two-side communication is very important. And if you feel any question, any queries, then be frankly ask. तर मी काय विचारलं क्वेश्चन की इंटरलेअर डिस्टन्स हे कशामध्ये जास्त आहे? कार्बन मोनोक्लोराइड मध्ये. कशापेक्षा? ग्राफाइट पेक्षा. तर हे डिस्टन्स जास्त असण्याचं कारण काय असेल? मयूर,
Yes, sir.
काय असेल जास्त डिस्टन्स जास्त असण्याचं कारण काय असेल? रिझन?
Sir, electrostatic force of attraction between molecules.
समवॉट इट इज करेक्ट. पण सिंपल मला पाहिजे. ग्राफाइट तुम्हाला स्ट्रक्चर आता मी दाखवलं, बरोबर का? यू सी वन्स अगेन, दिस ऑल आर द स्ट्रक्चर्स ऑफ ग्राफाइट्स. ओके. आणि आपण काय बघतोय? कार्बन फ्लोराइड्स. ओके. तर कार्बन फ्लोराइडचं स्ट्रक्चर हे आहे. तर सिंपल रिझन काय असेल? आणखी कोण? पूजा बाबर सांगता येईल का? पूजा बाबर. वैभव इतापे. वैभव, अनम्यूट युअर वॉइस. Anybody? 63 students are there and no anybody you want to give answer. What is that? So simple reason of this is due to the
Large number of carbon chloride covalent bonds in carbon monochloride.
okay. So this reason is what? This is due to the simple the what? What is the reason? Simple, because of the fluorine substitution. So if you see in case of graphite, okay, there is also layered structure, but there is carbon hydrogen, only carbon and hydrogen. But in case of what happened in carbon monochloride, instead of hydrogen there is a fluorine. So definitely the properties of hydrogen and fluorines are different. Okay. And fluorine, in case of all the properties, that is atomic size, electrostatic force of attraction, all these things are different than the hydrogen. That's why definitely there is a larger the distance between interlayer than what? Graphite. And this is because of what? Simple reason, that is fluorine substitution. Okay. So anybody say that each carbon from this each carbon from carbon monofluoride is hybridized. हे तर सांगता येईल आन्सर तुम्हाला. hybridized and forms four covalent bonds with other atoms in the same layer. Okay, each carbon from carbon monochloride is dot hybridized and form four covalent bond with other atoms in the same layer. तर काय असेल हायब्रिडेशन? कार्बन सिंगल बॉन्ड फ्लोरीन. हॅलो, हा बोला. काय झालं? नाही 90 मिनिटं येतो. तो नंबर दिलाय ना तुम्हाला, मोबाईल नंबर दिलाय ना. मॉक टेस्टचा जो मेसेज आहे त्याच्यामध्ये एक नंबर दिलाय ना तुम्हाला, मोबाईल नंबर फॉर एनी क्युरी. अहो दिलाय ना तुमच्या ग्रुपवरती, बघा. तर त्यांना कॉल करा, धन्यवाद सरांना. ठीक आहे, माझं लेक्चर आहे, मी तुम्हाला 10 मिनिटांनी कॉल करतो. मग सोडवा पटपट. आता आय डोंट नो व्हॉट काय नाव आहे. ठीक आहे, चालेल, मी करतो कॉल तुम्हाला. Sorry for interruption. You know that the MSA online exam starts from today and number of students facing the problem. Okay. तर कोणत्या टाईपचं हायब्रिडेशन असेल? हॅलो, अरे काय तुम्ही काय आन्सर देत नाही TYBSC. अंकिता चव्हाण आहेत का? अंकिता चव्हाण, गांधी, परिन गांधी, पूजा बाबर, धनश्री खराडे आहेत का? गायत्री कंसे, अविनाश चव्हाण. प्रेझेंटी घेणार म्हटलं की सगळ्यांचे माईक कसे अनम्यूट होतात आहे ना, आणि क्वेश्चन विचारला की कोणाचा माईक अनम्यूट होत नाही. तर कार्बन सिंगल बॉन्ड मध्ये जेव्हा तुम्ही एखादा कंपाऊंड तयार करता, फॉर एक्झाम्पल कार्बन अँड हायड्रोजन, मिथेन, तर मयूर कोणत्या टाईपचं हायब्रिडायझेशन असतं?
sp3.
ओके, मग आता इथं कोणत्या टाईपचा बॉन्ड आहे? कार्बन ही फ्लोरीन. ओके, तर इथं कोणतं हायब्रिडायझेशन असणार? कोणतं असणार? So each carbon from carbon monochloride is sp3 hybridized and forms four covalent bonds with other atoms in the same layer. For example, this is the one layer. Okay, and suppose this is the layer, and in that layer, suppose this carbon atom, sp3 hybridized carbon atom, and we see this one. Okay, so four covalent bonds formed with other atoms in the same layer. Then you see that this form one bond with this carbon, another bond with this carbon, then next bond with this carbon, and one bond with the fluorine in the same layer. Suppose if you take an example of this carbon, in this carbon also, this is the one bond, this is second, this is third, and this is fourth. So due to why? Because of the each carbon from carbon monofluoride is sp3 hybridized and forms four covalent bonds with the other atoms in the same layer. Okay, and this is the structure of what? Carbon monofluoride. This is structure of what? Carbon monofluoride. And whatever suppose this is the first layer and another one layer is there. Just I would like to show you. And suppose this is the first layer and this is the second layer. So what happened? What do we write here? The distance between interlayer is about 6.6. Just you see that. So this layer and this layer. Sorry. So the distance between these two layers is what? It is about 6.6 angstrom. Angstrom unit. Okay. So all of you understand this, the structure of carbon monofluoride, because sometimes short note asked in the case of carbon monofluoride. At that time, you should give the structure of carbon monofluoride. Okay, properties again the same as like here. That is the what is properties? There are may have color between gray and white. The electrical conductivity decreases with increasing flow content. Same properties are there, and their uses also same because they are used as a lubricants, adhesives, coatings, bearings, gaskets, non-sticking cooking appliances, etc. Okay, so all of you understand it? Yes or no? Yes or no?
Yes, sir.
Okay. So the next part of this topic is what? The next part of this topic is heteroatomic polymers. So anybody can what do you mean by heteroatomic polymer? Anybody explain? Yes or no? So if you see in the polymer black backbone, we have studied that homoatomic polymer backbone. Okay, and that homoatomic polymer backbone in which what we explain there? In heteroatomic polymer, the backbone framework of atom is of different atoms, and the examples is what? The example is what? Silicones and phosphonitrile compound. Okay, so from that we first see the silicones, and for the silicones structures, I think you see the structure of silicones in what? Condensation polymer. So silicons are what? Condensation polymer, and it is come under the class of what? It is heteroatomic polymers. So why it is called as hetero? If you see the structure here, the silicons are formed by removing the small molecule from its structure. That is, two monomeric units of silicons are combined together by eliminating what? This water molecule, and there is formation of what? This silicon polymer. Okay. Another, this silicon molecule. So that right here, from that another silicon molecule reacts. Again, the small molecule is removed, and the one silicon, second silicon, and third silicon attach to each other to form a polymeric chain. So in that case, there is a oxygen bond, that is oxygen metal in between these two silicons. If we see in case of chlorofluorocarbon, then fluorocarbon or phosphorus, in that case, phosphorus bond directly attached there. In case of chlorofluorocarbon, there is a carbon fluorine bond is there. But in case of silicons, what happens? The silicon is not directly attached with each other, but they attached with the help of oxygen, and that's why oxygen atom, silicon atom is present in their framework, and these two atoms are different, and that's why the silicons comes under the class of what? Hetero. Silicons is comes under the class of what? Heteroatomic polymers. Okay, all of you understand this one? Yes or no? Yes or no? Say something. All of you understand this?
Yes, sir.
So this silicons, okay, silicons are what? It is a organosilicon polymer, organosilicon polymer containing alternate covalently bonded silicon and oxygen. Okay. So in case of organosilicons, there is a covalently bonded silicons and oxygens are present. The remaining valences of silicon, the remaining valences of silicons that are satisfied by any organic groups, by any organic groups, like methyl, etc. Okay. So if you see the valences of silicons, that is one valency is attached with the oxygen. Okay. So silicons generally are what? Organosilicons polymer containing alternate covalently bonded silicon and oxygen. The remaining valences of silicons are satisfied by any organic groups like methyl or ethyl groups. Okay, and that's why suppose such a type of structure is there, they are they are they are called as siloxanes. Siloxanes. They are called as what? Siloxanes. So number of time the question asked on siloxane. What is meant by siloxane? So you should know that the siloxane is nothing but the polymer of what? Silicon. Okay. So this silicon also classified into different class like silicon fluids, silicon rubbers, silicon greases, silicon resin, depending upon their structure. Okay, depending upon structure and degree of polymerization. So silicons are classified into what? Silicon fluid 1, silicon rubber 2nd, silicon gases 3, greases and silicon resins. Okay, so according to their nature, that is, you know, that fluid, that is liquid, then rubber, that is which having the high elasticity, then greases, you know, the greasing is important for the functioning of the material, as well as silicon resins. Okay, so these are silicons are classified on their nature into 4 different classes. That's silicon fluids, silicon rubbers, silicon greases, and silicon resins. Okay, and that depend upon what? Their structure and degree of polymerization. Okay, all of you understand it? All of you understand or not? Hello, Mayur.
Yes, sir.
Okay. So when I am asking something, then immediately unmute your mouth and you say something. Then I would like to understand it. Okay. So Amruta, I would like to take present it. Amruta Ingre. Amruta Ingre. Ankita Sawan. Yes, I am audible or not, Mayur?
Yes, sir, you are audible.
मग हे आन्सर का देत नाहीत? इंगळे, अंकिता चव्हाण लेक्चरला प्रेझेंट आहेत का नाही? So I just I note down your names. Okay. Then Ankita Kanse. They are present or no? I have doubt. Then Avinash Chavan. Bagde Akanksha.
Present, sir.
Bagal Akshata. Bagal Akshata. Bhavna Jadhav.
Present, sir.
Dhanashree Kharade.
Present, sir.
Dipti Dhanavde.
Present, sir.
Then Gayatri Kanse. Gayatri Kanse. Ghadge Akash.
Present, sir.
Yes, sir.
Kedar Bhosle.
Present, sir.
Kishori Gore.
Present, sir.
Komal Chavan. Komal Chavan. Komal Bhosle.
Present, sir.
Manisha Kevde.
Present, sir.
Mayur Jagtap.
Present, sir.
Mayuri Kanse.
Present, sir.
Monali Gaikwad.
Present, sir.
Monica Kardure. Neha
Present,
Anubhav. Neha Katkar.
Present, sir.
Neha Katkar.
Present, sir.
Nika Gaikwad.
Present, sir.
Then ओमकार जगताप.
Present, sir.
करीम गांधी.
प्रेझेंट सर.
गांधी, मगाशी तुमचा आवाज येत नव्हता का? गांधी.
हा काय म्हटलं सर?
तुम्ही आन्सर देत होता तो तुमचा आवाज येत नव्हता का? नेटवर्क प्रॉब्लेम होता का?
हा.
ओके. देन पूजा बाबर. पूजा बाबर. पूजा भोसले.
प्रेझेंट सर.
पूजा घाडगे. प्राची जाधव.
प्रेझेंट सर.
प्रेझेंट
प्रगती
सर.
कदम.
प्रेझेंट सर.
प्रणिता. प्रणिता.
प्रेझेंट सर.
हॅलो. नाव काय तुमचं? काय पुन्हा? प्रणिता मोरे का? ओके, ठीक आहे. 1-2 मिनिटं थांबा, मी लेक्चर तुम्हाला कॉल बॅक करतो. पूजा घाडगे झालं का? प्राची जाधव. प्राची जाधव.
सर. प्रेझेंट सर.
प्रगती कदम.
प्रेझेंट सर.
प्रतीक्षा कदम.
प्रेझेंट सर.
प्रतिमा भोसले.
प्रेझेंट सर.
पूजा जाधव.
प्रेझेंट सर.
पूनम चौधरी.
प्रेझेंट सर.
रोहित गायकवाड.
Present, sir.
ऋतिक जगताप.
Present,
ऋतिक जगताप. ऋतुजा भोसले.
प्रेझेंट
ओके.
सर.
सचिन जाधव.
Present, sir.
साक्षी गोरे.
प्रेझेंट सर.
संकेत डोलटडे.
Present, sir.
सायली अवघडे. सायली अवघडे. सायली भिसे.
प्रेझेंट सर.
सीमा बाबर.
प्रेझेंट सर.
देन शीतल भुजबळ.
प्रेझेंट सर.
शीतल चौधरी.
प्रेझेंट सर.
शिवानी भोसले.
प्रेझेंट सर.
शिवानी इथापे.
प्रेझेंट सर.
श्रद्धा भुजबळ.
प्रेझेंट सर.
श्रेया ऐरेकर.
प्रेझेंट सर.
श्रुती जाधव.
प्रेझेंट सर.
सोमनाथ गुरव.
Present, sir.
सोनल भगत.
प्रेझेंट सर.
तनुजा जाधव.
प्रेझेंट सर.
तनुजा जाधव.
प्रेझेंट सर.
वैभव इथापे.
Present, sir.
वैष्णवी जगाळे.
प्रेझेंट सर.
विनोद बले.
Present, sir.
Okay, once again, this student अमर इंगळे. अमर इंगळे. अमृता इंगळे. अमृता इंगळे. अमृता इंगळे, your voice is not audible. अंकिता चव्हाण.
प्रेझेंट सर.
अंकिता, किती वेळ तुम्हाला प्रेझेंटी द्यायला?
सॉरी अजून आवाज येत नाहीये, कट होतोय मधून मधून.
अश्विनी कलसे.
प्रेझेंट सर.
अतुल बनसोडे.
Present, sir.
थोडस प्रेझेंटेशनच्या बाबतीमध्ये सिरियसली घ्या. जर तुम्हाला काय प्रेझेंट वगैरे देता आलं नाही लेक्चरला जर प्रेझेंट असाल तर तुम्ही सरांना डायरेक्ट कॉन्टॅक्ट करून सांगायचं सर मी लेक्चरला प्रेझेंट होतो. ठीक आहे. थोडस डिफिकल्टीज आहे ऍडव्हान्टेज चांगल्या प्रकारे घ्या असं तुमचं
सर आवाज ब्रेक होतो.
म्हणजे तुम्हाला रेंज नसणार. आणि जे काय आहे ते तुम्ही लगेच सांगायचं की सर आवाज ऐकू येत नाहीये किंवा व्हिज्युअलाइज होत नाहीये. ठीक आहे. सेकंड लेक्चर कोण मयूर सेकंड लेक्चर कोणाच आहे?
हा सर.
कोणाच आहे सेकंड लेक्चर? माहित आहे की नाही? हॅलो अरे सेकंड लेक्चर कोणाच आहे? तर करूया आपण कंटिन्यू.
कोकाटे सरांचं.
हॅलो सर आहे
सर जॉईन झाले?
हा
जॉईन झाले सर? जॉईन झालेत का?
हो येस येस
ओके ओके सर. जस्ट आय हॅव यू. ओके थँक यू. हॅव अ नाईस डे.
गुड आफ्टरनून वन एंड ऑल. Am I audible?
Yes, sir.
Yes, sir.
Okay, good. So we'll start the new SSI, small scale industry. मागच्या वेळेस आपण बघितलेले आहेत दोन. मागच्या वेळेस कुठल्या इंडस्ट्री बघितलं आपण कोण सांगेल? Last time we discussed 2 points or 2 industries. Just let me know what are the names of that. Anyone, or if you can write down in chat box, no problem. चॅट बॉक्स मध्ये लिहा. Okay, shoe polish and plaster of Paris. Okay, very good. Okay, thank you. त्या दोन्ही इंडस्ट्रीज एकदम सिंपल होत्या. ठीक आहे. So these are the very simple industry. Just need some small instrument and small manpower. You can start your own industry. That's a big deal. And nowadays we get a financial support from the government or bank if you want to start any business. Okay. Now we will discuss another 2 small scale industry. One is the one is the silicon carbide crucible, and second is the writing and fountain pen ink. Okay. These are the simples. Let me share the presentation. Okay. Can you see the presentation? One website is there.
Yes, sir.
Okay, so this is our next small scale industry. The name of that product is the silicon carbide crucible. Okay. तुम्ही क्रुसिबल वापरलेलं लॅब मध्ये इनऑर्गॅनिकचे प्रॅक्टिकल वेळेस. त्या क्रुसिबलचं नाव काय होतं? इनऑर्गॅनिक केमिस्ट्री मध्ये वापरतात आपण. What is the name of that crucible you use for the inorganic practical? Instead of writing chat box, just turn your mic on and reply. कुठली क्रुसिबल वापरतो आपण इनऑर्गॅनिक प्रॅक्टिकलला? Are answer simple question.
Ceramic crucible.
Ceramic crucible. Okay. अजून तुम्हाला कुठले क्रुसिबल माहित आहेत का? Okay. So today's discussion is on the silicon carbide crucible. Crucible म्हणजे माहिती आहे तुम्हाला. You have seen that crucible in the TIVA practical. Now these are the made of the silicon carbide materials. Okay, so you can see that its application where you can use this silicon carbide crucible and the different size of the silicon carbide. Actually, these are used in the foundry industry. Foundry industry means where you can melt other metals. Okay, and then these molten metals give the particular shape for the proper size and for proper application. For the melting purpose, we need this crucible. Okay, so you can see that different pictures are there and different silica carbide crucible is there. Okay, now we will discuss the material, its property. Okay, what is meant by silicon carbide material and how these crucibles are made. Okay, so these silicon carbide crucibles are generally made of the carbon bonded silicon and graphite materials. Okay, so this is the raw material and how it is made is written there. So these are made of carbon bonded silicon and graphite material. So these silicon carbide crucibles are suitable for smelting and melting precious metal. जे फाउंड्री मध्ये असते, फाउंड्री मध्ये काय करतो आपण, अल्युमिनियम असेल किंवा आयर्न असेल किंवा बाकीचे जे मटेरियल असतात, जे मेटल्स असतात, त्यांचं मेल्टिंग पॉइंट अबव 1500 डिग्री सेल्सिअस असतो. ओके, असे मेटल मेल्ट करण्यासाठी एक आपल्याला क्रुसिबल लागते, म्हणजे बरोबर आहे. आणि ती क्रुसिबल कशी पाहिजे आपल्याला, की हाय टेम्परेचर सस्टेन, हाय टेम्परेचर सस्टेन झाली पाहिजे. आणि वन ऑफ दिस इज सिलिकॉन कार्बाइड. Okay, so these crucibles are used for the melting precious metal, okay, base metals and other metals in a induction furnace. Furnace म्हणजे तुम्हाला माहित आहे, तसेच मोठे मोठे फर्नेस असतात, त्याच्यामध्ये पण आपण हे क्रुसिबल ठेवून आपलं ऍप्लिकेशन जे आपल्याला युजेस पाहिजे ते करू शकतो. ओके, and the temperature that at around 1600 degrees Celsius they are operated. So you can imagine the how much hot temperature is there. Okay, जरी आपल्याला एक 45 डिग्री सेल्सिअसचा टेम्परेचर जरी आपल्याला बर्न झालं तर आपली स्किन हे होते, पण 1600 डिग्री सेल्सिअस म्हणजे किती टेम्परेचर हॉट असेल ते तुम्ही इमॅजिन करू शकता. ॲट दॅट टेम्परेचर वी यूज दिस मटेरियल ॲज अ क्रुसिबल because this crucible offer a uniform and consistent temperature when melting and has a high strength and resistance to cracking. Okay, जर तुम्हाला प्रश्न विचारला का why silicon carbide crucibles are used, here is the reason. Because they are uniform, consistent temperature means overall जेवढा त्याचा क्रुसिबलचा पार्ट आहे त्याच्यामध्ये पूर्णपणे टेम्परेचर युनिफॉर्म असते. ओके, and when melting and has a high strength and resistance to cracking, so it doesn't get easily cracked. So this uniform temperature gives a high quality molten metal. त्यामुळे तुमचे जे मेल्टिंग होतं मोल्ट मेटलचं ते चांगल्या प्रकारे होऊ शकते, because molten metal is required for the casting, okay, long lasting and good quality metal products. म्हणजे जर आपण लोखंडापासून आपण वेगवेगळ्या प्रकारचे मटेरियल्स बनवतो, फॉर एक्झाम्पल रेल्वेचं चाक असेल किंवा रेल्वेचं रोल असेल, ओके, किंवा मोठ्या मोठ्या मशिनरी असतात, क्रेन असतात, अशा प्रकारचे जे लोखंड असतात किंवा जे मेटल असतात त्याचं चांगली आपल्याला स्ट्रेंथ पाहिजे, त्याचा साईज व्यवस्थित पाहिजे, त्यासाठी त्यांना मेल्ट करावं लागतं आणि मेल्ट करण्यासाठी आपण हे क्रुसिबल वापरतो. त्याची साईज वेगवेगळी असू शकते. ओके, so this silicon carbide crucible have good thermal conductivity, high strength, low thermal expansion, oxidation resistance, resistance to the thermal shock, resistance to wetting, and high hardness and wear resistance. So it has so many good properties And this property make this silica crucible useful. Okay, so due to this silicon carbide crucible property, it is applicable in various industries. मग त्याचा कुठे कुठे उपयोग करू शकतो, as such as chemical, electrons, semiconductor, and metallurgy, etc. So these are the some industry where you can use this material. Okay. You can see that different size of the crucible we can prepare, we can manufacture. Here you can see that the height is there, inner diameter, outer diameter, and base. Okay, so according to this our requirement, we can prepare different size of the crucible. Okay, now this is the application of silicon carbide crucible. Okay, जे आता आपण डिस्कस केलं तेच आहे, त्याच्या प्रॉपर्टी काय ते सांगितलेलं आहे. Here you can see that the different silicon carbide crucibles. Here are the features and advantages of silicon carbide graphite crucibles. काय काय advantage आहे? For example, silicon carbide and graphite are the two main raw material used in the production of the silicon carbide graphite crucibles. These two materials have their own unique property. आपल्याला माहिती आहे ग्राफाइट किती स्ट्रॉंग आहे, ठीक आहे, किंवा कार्बाइड किती, सिलिकॉन कार्बाइड जे आहे यांचं मिक्स करून डायमंड सारखं मटेरियल तयार होतं. सो इट हॅज व्हेरी गुड क्वालिटी and make them these materials of choice for high quality crucible productions. Okay, it is an important non-oxide ceramic which has diverse industrial applications. आता ऑक्सिडेशन होत नाही किंवा त्याचं ऑक्सिडेशन होत नाही म्हणजे काय, ज्यावेळेस आपण हिटिंग करतो ॲट हाय टेम्परेचर अराउंड 1600 degrees Celsius, there sometimes get oxidized, some metals are get oxidized, but in this case, कुणाचं तर माईक चालू आहे, जस्ट टर्न ऑफ दॅट माईक.
ही बाटली मला भरून द्या, मी बसली.
प्राची जाधव. Okay. Okay, so silicon carbide is an important non-oxidic element. तसं ते ऑक्सिडाइज होत नाही, त्यामुळे त्याची स्ट्रेंथ आहे तशी राहते. ओके, and because of this hardness and strength, chemical and thermal stability, high melting point, and as a melting point 100 पेक्षा जास्त असणार ऑब्वियसली, कारण का आपण हे वापरतोय मेल्ट करण्यासाठी एखादं मेटल अराउंड 1600 degrees Celsius. So this silicon carbide has high melting point than the other metals. Okay. So these are the some properties in details. High resistance to thermal shock. हे जास्त डिटेल द्यायची गरज नाहीये, त्याच्यावर तुम्हाला लक्षात येईल. जरी टेम्परेचर जास्त असेल तर त्याला काही होत नाही थोडक्यात. देन हाय रेजिस्टन्स टू इरोजन, गंजत नाहीये मटेरियल. So this flow of molten metals and charging the crucible with solid metal can lead to our abrasion and erosion of the inside wall of the crucible. But this thing doesn't happen with this type of crucible. The next property is the high resistance to chemical attack by fluxes and slags. Okay. The next property is the due to their carbon content. आता आपण माहिती बघितलंय, we are use graphite as a raw material for the manufacture. So because of this carbon content, this has good excellent stability at higher temperature, and therefore suitable for process where the temperature is changing frequently and where high heat rates are utilized. Okay, so this carbon gives the strength to the crucible. Then next one is the quality stability. So whatever the quality we get after the manufacturing, it remains for a long time. Okay, so we can say that this quality is sustained for the over the period of time. Okay, then next is the high resistance to atmospheric oxidations. Oxidation होत नहीं है. Then high mechanical strength and high refractoriness. Next one is silicon carbide graphite crucibles suitable for use in a electrical resistance furnace. म्हणजे जिथं जिथं आपल्याला हाय टेम्परेचरचं अडचण येते त्या ठिकाणी आपण हे क्रुसिबल्स किंवा हे मटेरियल्स वापरू शकतो. ओके, So these are the properties. खूप सारे हैं. So these are some images of the crucibles of different sizes, from very small to higher one. You can prepare any size of the crucibles as per the requirement. Okay, the next part is टाइप्स ऑफ फर्नेस. हा नाही आपल्याला जास्त काही इम्पॉर्टंट नाहीये. जसं आपल्या लॅबमध्ये फर्नेस आहे तसे वेगवेगळ्या प्रकारचे फर्नेस असतात, बट वी आर नॉट गोइंग इन डिटेल्स. The main part is the raw materials. Okay. So here this is the important point. If you want to prepare this silicon carbide graphite crucibles, then you can prepare, and you must know the raw materials. Okay, the raw materials, silicon carbide and graphite, are graded to the required size and mixed with bonding materials. आता ज्यावेळेस आपण हे मटेरियल घेतो त्याच्यामध्ये काही बॉन्डिंग मटेरियल्स ऍड करावे लागतात. ओके, लाईक molten pitch or other suitable synthetic resins in suitable proportions. जर कुठली इंडस्ट्री असेल तर ते त्यांचं प्रोपोर्शन सांगत नाही सहसा. सो वी हॅव टू ट्राय आवर सेल्फ फॉर अ गुड क्वालिटी. ओके, so when you have a silicon carbide, this is the first material, raw material, then second is the graphite, and in that mixture we have to add bonding materials like molten pitch or other suitable resins in a suitable proportions. Okay, then this near homogeneous mixture is charged under a specific technical process. त्याच्यानंतर आपण टेक्निकल प्रोसेस करून त्याचं होमोजेनियस मिक्सचर बनवावं लागतंय. Okay, so you'll get the fine powder, and after that the total mass of mixture is mold. Total mass of the mixture in the mold is kept in a uniform hot condition to avoid manufacturing defect with while pressing. ज्यावेळेस आपल्याला हे मिक्सचर तयार होतं त्यावेळेस एखाद्या मोल्ड मध्ये आपल्याला ठेवावं लागतं जिथे त्याची हिटिंग प्रॉपर असेल. असं काय करावं लागतं, कारण जर ज्यावेळेस आपण क्रुसिबल बनवायला जाऊ त्यावेळेस क्रॅकिंग होणार नाही किंवा त्याच्यामध्ये काही डिफेक्ट्स तयार होणार नाही, त्याची आपल्याला काळजी घ्यावी लागते. ओके, सो दिस टिपिकली सिलिकॉन कार्बाइड इज प्रोड्यूस युजिंग द एचएन प्रोसेस विच इन्व्हॉल्व्स. जर तुम्हाला सिलिकॉन कार्बाइड मटेरियल बनवायचं असेल, यू कॅन प्रिपेअर दॅट मटेरियल बाय युजिंग दिस प्रोसेस. लक्षात असू द्या, जर एमसीक्यू प्रश्न विचारला which process is used to produce silicon carbide, then your answer must be HFN process, which involves heating silica sand and carbon to high temperature in an HFN graphite resistant furnace. Okay, so this is the name of the scientist, okay, who first time produced the silicon carbide. That's why their name is given to this process. Okay, तर आपल्याला सुरुवातीला काय करावं लागतं, सिलिका सँड आणि कार्बनचं मिक्सचर हाय टेम्परेचरला हीट करावं लागतं, जे फर्नेस असेल त्याच्यामध्ये ठेवून. ओके, then it can be formed as a fine powder or a bounded mass that must be crushed and milled before it can be used as a powder feedstock. ज्यावेळेस आपण त्याला हीट केल्यानंतर त्याच्यापासून जे आपल्याला मटेरियल मिळेल त्याला आपल्याला फाइन पावडर मध्ये कन्वर्ट करतात. सो यू नीड टू डू सम क्रशिंग और सेविंग म्हणजे काय, चाळणीमधनं मोठे मोठे पार्टिकल्स रिमूव्ह करून परत त्याचं क्रशिंग करून परत ते आपण स्मॉल पार्टिकल किंवा फाइन पावडर मध्ये कन्वर्ट करू शकतो. ओके, सो वन्स दिस सिलिकॉन कार्बाइड इज इन ए पावडर फॉर्म, द ग्रेन्स ऑफ द कंपाउंड्स आर बाउंडेड टुगेदर. त्याच्यामध्ये काही आपण ऍड करून, so these chemicals are bounded by the sintering to form a very useful ceramic materials which has a wide range of uses including foundry. Okay, so this way you can prepare the silicon carbide materials. The next second raw material is a graphite one, is mined both on surface quarry and underground. हे आपल्याला मिळू शकतं कुठे कुठे. ओके, the surface quarry involving mining graphite from an open pit or grow mining जिथे होतं तिथनं आपल्याला हे मटेरियल मिळू शकतं. Okay, so all these process have to pass through to get a natural and high quality raw materials. Means we have to make sure that whatever the material we have, we are getting from somewhere, it must be a good quality. Then and then we have the very high quality silicon carbide crucible. Otherwise, what will happen? If you are getting the poor quality, so automatically there will be defect in your carbide crucibles. So to avoid, make sure that you have get the pure quality materials. Okay. Now once you have these raw materials, okay, silicon carbide and graphite, then you can have to add additive such as the ferrosilicon, ferromanganese, etc. So the name of this compound is ferrosilicon and ferromanganese, which act as the additives. These are the graded to the required sand and mixed with the bonding material like molten pitch or other suitable synthetic resin in suitable proportions. So once the mixing is done, next is the mixing is done in the milling. मिल म्हणजे काय, जिथं मोठ्या प्रमाणामध्ये मिक्स केलं जातं. आता आपण ज्यावेळेस सिलिकॉन इंडस्ट्री करू त्यावेळेस आपण जे मटेरियल घेणार ते इन केजी असेल. ओके, so we are not going with the gram or milligram, so we will use the some kg amount. So to mix all these materials, we need the mixing machine, that is called milling machine. Okay, so here mixers, when the bonding materials are in a molten condition, त्यास आपण molten condition मध्ये त्याला हे करून त्याचं चांगलं mixing करू शकतो. And then you have the homogeneous mixture, and this homogeneous mixture is charged into an injection type crucible die. आता हे जे मिक्सचर झालं होमोजेनियस, ते आपल्याला काय करायचं आहे, ज्या साईजची क्रुसिबल आपल्याला बनवायची आहे त्या मोल्टन डाय मध्ये पोर करायचं. डाय मध्ये केलं तर काय होईल मग, की जे डायची साईज आहे ती साईज त्या क्रुसिबल मटेरियलला मिळेल. ओके, so just eject your homogeneous mixture to crucible die fitted on a hydraulically operated roller press. Okay, जिथे आपल्याला हे मटेरियल प्रेस करावं लागेल. Okay, so while pressing operation is ongoing, the total mass of mixture in the mold is kept in uniform hot condition to avoid manufacturing defect. Okay, ती थोडीशी आपल्याला काळजी घ्यावी लागते, नाहीतर त्याच्यामध्ये काही डिफेक्ट्स तयार होतात. सो टू अवॉइड दिस डिफेक्ट्स, uniform heating is required, or uniform hot temperature must be there, then we have the good quality. Okay, so this way you can prepare any type or any size of the silicon carbide crucibles. याच्यामध्ये दोनच important materials आहे raw. One is the silicon carbide, second is the graphite, and the secondary materials are the additives, okay, or bonding materials. ठीक आहे, त्याच्या व्यतिरिक्त जास्त काही मटेरियल लागत नाही. Okay, then you can check the quality of the silicon graphite crucible by doing some test, quality test, durability test. Okay, then temperature test you can do it. So once you do all these tests, you come to know that the quality. Okay, so this is not important. Now I have one site. Okay, जसं मी तुम्हाला सांगितलं synthesizing silicon carbide, it is called the HSN process. Okay, so it is here. So this silicon is produced using the HSN process, which involves heating the silicon sand and carbon to high temperature. Okay, so here you can get the process how this is done. And now next part is the structure of the silicon carbide. आता जे मटेरियलचं आपण क्रुसिबल बनवले त्याचं स्ट्रक्चर काय आहे. Okay, so the many structures of polytypes have been identified for silicon carbides. त्याचे वेगवेगळे प्रकारचे स्ट्रक्चर शोधलेले आहेत. Okay, these polytypes have different stacking arrangement for the atoms of silicon and carbon in the compound. Okay, तर तुमच्या लक्षात आलं असेल की याच्यात atoms कुठले आहेत. One is the silicons and second is the carbons. So these silicons and carbons are arranged in a many way. That's why we have the many structures or polytypes. Okay, one of the simplest structure is the diamond structure, which is known as the BSIC. Okay, its structure is like the diamond one. Okay, there are more complex hexagonal or rhombic structure of the compound, and these are designated as silicon carbide, SiC. म्हणजे आपल्या इथे दोन स्ट्रक्चर लक्षात येतील. वन इज द डायमंड टाइप ऑफ स्ट्रक्चर and second is the simple SiC. SiC means it has more complex hexagonal and rhombic structure. ठीक आहे, एमसीपीच्या दृष्टीने हे खूप महत्वाचं आहे. जसं मी तुम्हाला सांगितलं की हे सिलिकॉन कार्बाइड कसं डिस्कवरी झालं, आणि त्या सायंटिस्टचं नाव होतं डॉक्टर एडवर्ड गोल्ड्रिच एचसन, who was the first scientist who worked on the who produced this silicon carbide. आणि ह्या सायंटिस्टनं थॉमस एडिसनच्या हाताखाली काम केलेलं आहे. सो इज द स्टुडंट ऑफ द थॉमस एडिसन, तुम्हाला सर्वांना माहित आहे. ओके, आणि ह्यानं कसं प्रोसेस किंवा कुठली प्रोसेस केली आणि ह्याला सिलिकॉन कार्बाइड कसं मिळालंय त्याची इथं तुम्हाला डिटेल्स आहे. ओके, the next point to be remembered is the types of silicon carbide. ओके, कुठले कुठले सिलिकॉनचे टाइप आहे सिलिकॉन कार्बाइडचे ते तुम्हाला माहित पाहिजे. So for commercial engineering applications, silicon carbide products are produced in three forms. वेगवेगळे ऍप्लिकेशन असते त्यामुळे आपल्याला वेगवेगळ्या फॉर्म मध्ये बनवावं लागतं. द फर्स्ट वन इज द सिंटर्ड सिलिकॉन कार्बाइड, SSC. Next one is the nitride bonded silicon carbide, and third one is the reaction bonded silicon carbide. Okay, SSC means sintered, NBSC means nitride bonded silicon. So there will be nitride groups compound. Okay, and the last one is the reaction bonded silicon carbide, that is the RBSC. You can also prepare some other types of silicon carbide by adding the clay materials. Okay, then it will be called clay bonded silicon carbide. Okay, and Sion, SiAlon, bonded silicon carbide. Okay, so there is also chemical vapor deposit silicon carbide called the CVD. Silicon means it is chemical vapor deposit silicon carbide, which is an extremely pure form of the compound. जर तुम्हाला चांगले क्वालिटी पाहिजे मल्टिंग ऍप्लिकेशन, देन यू कॅन प्रिपेअर द CVD silicon carbide. CVD means chemical vapor deposited chemical silicon carbide. Okay. The center the silicon carbide is necessary to add sintering aids, which helps to form a liquid phase at the sintering temperature, which allows the grains of silicon carbide to bond together. ठीक आहे, तर सिंटरिंग काय करायला लागतं ते सांगितलेलं आहे. जर तुम्हाला काही ठिकाणी सिंटरिंग सिलिकॉन कार्बाइड वापरावं लागतं. ओके, त्याचं काही ऍप्लिकेशन असेल किंवा ते जर मटेरियल लागत असेल तर त्याच्यामध्ये आपल्याला सिंटरिंग एड्स ऍड करावं लागतं. ओके, त्यामुळे त्याची प्रॉपर्टी चांगली होते. सो जस्ट रिमेंबर द दिस टाइप्स ऑफ द सिलिकॉन कार्बाइड क्रुसिबल्स. आणि जर तुम्हाला जास्त डिटेल मध्ये प्रॉपर्टीज पाहिजे असेल तर हिअर वन टेबल इज देअर, यू कॅन गो थ्रू. इट हॅज डिफरंट प्रॉपर्टी अँड इट शोज द दिस प्रॉपर्टी आर व्हेरी गुड टू यूज दिस मटेरियल इन द मेटलर्जी और फाउंड्री इंडस्ट्री. ठीक आहे, सो दिस इज अबाउट द सिलिकॉन कार्बाइड क्रुसिबल्स. याच्यात तुम्हाला काय लक्षात ठेवायचं आहे? द रॉ मटेरियल, the process कुठली आहे, by which process the silicon carbide material is produced. ओके, स्ट्रक्चर एक लक्षात ठेवा. स्ट्रक्चर नंतर त्याच्या काही थोड्या प्रॉपर्टी सुरुवातीच्या, त्याचे टाइप्स आणि मॅन्युफॅक्चरिंग प्रोसेस, हे 4 ते 5 गोष्टी तुम्हाला लक्षात ठेवाव्या लागतील. ओके, नाउ वी आर गोइंग टू डिस्कस द अनदर point is the fountain pen ink. Okay, कदाचित तुम्ही फाउंटन पेन वापरलेला असेल, इंक पण वापरलेला असेल. ठीक आहे, वापरले का कोणी पेन, तो फाउंटन पेनचा? आजकाल सर्वांकडे बॉल पेन असतो बरोबर, त्याच्यामध्ये रिफिल असते. पण पहिले सुरुवातीला त्याच्या अगोदर फाउंटन पेनचा वापर खूप व्हायचा. तुमच्याकडे आहे का तसं काय एखादा फाउंटन पेन? एनीवन? वापरलेला आहे का नाही तुम्ही कधी फाउंटन पेन? हो या नो, ऐसा नो. Okay, I will show the one image of fountain pen so you will get idea. Okay, तुम्ही दिसत असेल तुम्हाला राइट साइडला फाउंटन पेन, त्याला आपण निप म्हणतो. ओके, these are the now old pens but it has very important value, or you can use as a standard one. ओके, मनीषा said that yes. ओके, त्यांनी वापरलेला आहे. ठीक आहे, तर ह्या फाउंटन पेन मध्ये जी इंक आहे, ओके, ती इंक कशी बनवली जाते किंवा त्याच्यामध्ये काय कॉम्पोजिशन आहे हे आपल्याला बघायचं आहे. ओके, so we are going to discuss the fountain pen ink. So remember that fountain pen ink is a water based ink, okay, intended to for use with fountain pen. ठीक आहे, तर ज्या फाउंटन पेन मध्ये जी शाई असते ती काय वॉटर बेस्ड इंक आहे. आता इंक म्हणजे काय? सो इंक इज अ जेल or solid or a solution that contains at least one colorant such as the dye or pigment and is used to color a surface to produce an image, text or design. ठीक आहे, इंक म्हणजे काय? जेल असेल किंवा सोल्युशन असेल किंवा सोल्युशन असेल ज्याच्यामध्ये एक कलरंट असतो. दॅट कलरंट इज फ्रॉम द आयदर डाय और पिगमेंट. तुम्हाला डाय माहित आहे, पिगमेंट पण माहित आहे. ओके, and this color is used on a surface to produce a image or text or design. Clear? So what is the composition of ink? Okay, so here is the detailed composition of the ink. So you can get this from the Wikipedia. Wikipedia मध्ये खूप डिटेल दिलेला आहे आपल्याला हे. ठीक आहे, so fountain pen ink is almost exclusively dye based because fountain pen operate on the principle of capillary actions. तुम्हाला कॅपिलरी ऍक्शन माहित असेल. ओके, कॅपिलरी ऍक्शन म्हणजे आपण जे क्रोमॅटोग्राफी मध्ये बघतो किंवा नारळ झाड्या पाण्यामध्ये वर परत पाणी जातं नारळामध्ये. ठीक आहे, सो दिस बिकॉज ऑफ द कॅपिलरी ऍक्शन्स and the same action is take place in working of the fountain pen. Okay, and this ink is dye based. Okay, there is a ink which is based on the pigment. Pigment म्हणजे काय? It is a colored material that is completely or nearly insoluble in water. In contrast, dyes are typically soluble. तर पिगमेंट आणि डाय मध्ये तुमच्या फरक लक्षात येईल की डाय हे सोल्युबल असतंय पण पिगमेंट इनसोल्युबल आहे. ओके, dyes are generally organic compounds whereas the pigments are often inorganic compounds. Okay, जास्त डिटेल्स बघूया आपण. अगोदर आपण कॉम्पोजिशन बघूया. So this is the principal capillary action and this pigment based ink which contains solid pigment particle in a liquid suspensions, okay, tend to clog the narrow passage of the pen. आता ज्यावेळेस आपण पेन वापरतो, जर तुम्ही हे मटेरियल वापरलं, आपल्याला माहित आहे की पेनची असेल की बॉल पेन असेल किंवा हे फाउंटन पेन असेल, त्याचं टोक एकदम बारीक असतं, म्हणजे त्याचा जो रूट असतो तो एकदम नॅरो असतो. अशा वेळेस ब्लॉक होण्याचे चान्सेस जास्त असतात नीप, बरोबर. दिस नीप कॅन गेट ब्लॉक्ड बाय दिस मटेरियल्स और डाय. So we have to find the solution to avoid this blocking or clog of the material. Okay. Indian ink, जर आपण भारतामध्ये बघितलं असेल तर इंडियन ink is a simple black or colored ink, once widely used for writing and printing and now more commonly used for the drawing and outlining. Okay, so एक कार्बन पिगमेंट बेस्ड इंक आहे, जे आपल्या भारतामध्ये होते इंडियन इंक. It is a pigment based ink. Also contains a binder. So these are the other materials used to get the better quality of the ink. काय binder आहे, gum arabic आहे, which can quickly clog such pen. So the ideal fountain pen ink is free flowing, free of sediment and non-corrosive. Okay, and this quality may be compromised in the interest of permanence. जर तुम्हाला त्याच्या काय क्वालिटी मध्ये चेंजेस करत असतील तर तुम्ही करू शकता. So there is not a any company does not open their secret compositions. Okay, so you have to prepare your own composition to get the good quality ink. For example, now next is the a form of ink that predate fountain pens by century is a iron ball ink. आता थोडी हिस्ट्री आहे, ठीक आहे, हे तुम्हाला हिस्ट्री वाचू शकता. हिस्ट्री आपल्याला काही एवढी गरज नाहीये. आपलं मेन काय आहे तर इंक आहे आणि त्याचं कॉम्पोजिशन आहे. ओके, जर तुम्हाला प्रश्न विचारला की व्हॉट इज द मेन कॉम्पोजिशन ऑफ द रेड इंक और ब्लैंक इंक और ब्लू इंक, and answer is here. The red ink usually contains a dye kerosene. So this is the dye used for the red colored ink, and this is the structure of the this dye. Okay, you can see the structure. The blue ink of this blue ink often contains triaryl methane dye. Okay, so triaryl means there will be 3 benzene rings, methyl groups. Okay, and this is synthetic organic compound containing triphenyl methane backbones. त्याच्यामध्ये 3 benzene rings methane group असा असेल. Okay, जर blank ink पाहिजे असेल, so blank inks are mixtures in addition to water and non-dye components. Okay, these other methods may include polymeric resin, okay, to retain the premature dyeing, pH modifiers or anti-foaming agents, polaroids to prevent fungal and bacterial growth. So these are the some methods we have to add to avoid such things like the if you want to avoid the fungal or bacterial growth, then we have to add some biocides. Okay, foam जर avoid करत असेल तर then we have to add the anti-foaming agents. Okay, then surfactant is added to avoid the wetting problem. Okay, and these surfactants reduce the surface tension of the ink. Okay, now we know that the surface tension of water is 72 dyne per centimeter, but the desirable value for ink is between 38 to 45. Okay, if the ink surface tension is very too high, then it would not flow through the pen. Okay, तर त्यामुळे त्याचं आपल्याला सरफेस टेन्शन जे आहे इंकचं ते कमी करावं लागतं, नाहीतर काय होईल, त्याचं फ्री फ्लोईंग होणार नाहीये, स्मूथपणे ते बाहेर येणार नाही आणि तुमचं अक्षर किंवा तुम्ही जे काय लिहाल किंवा जे काय करचाल ते व्यवस्थित होणार नाहीये. ओके, देर इज नो पर्टिक्युलर कॉम्पोजिशन. आता कसं असतं, आता हे कंपनी बनवत असते त्यामुळे कोणी त्यांचं कॉम्पोजिशन सांगत नाहीये, फक्त पण आपल्याला लक्षात येते की याच्यामध्ये काय काय मटेरियल असू शकतात. त्याच्यामध्ये डाईज असू शकतो, त्याच्यामध्ये बायोसाइड असू शकतो, अँटीफोमिगेशन असतो, पीएच मॉडिफायर असू शकतो. ओके, सो वी हॅव टू ऍड ऑल दिस compounds, different types of compound in a suitable composition, and that composition is derived by the chemist person, or you can also find out that composition by just mixing the various amount. Okay, so this is about the chemical composition of the ink. I have one more slide, how ink is made. ओके, इथं पण तुम्हाला इंक कसं तयार करता येईल ते पण सांगितलेलं आहे. ओके, दिस इज जनरल. ठीक आहे, याच्यामध्ये जास्त काय नाहीये. इंक कुठून आलेलं आहे त्याची हिस्ट्री आहे. सो यू कॅन सी दॅट अराउंड 1200 BC an inventor from the China named In Chiu created a black ink for writing by experiment with pine tree fruit and lamp oil. तर तुमच्या लक्षात येईल की चायनीज लोकांनी सुद्धा सुरुवातीला बनवलेलं आहे. ओके, so this is the history. In India, you can say that around the 4th century, an ink known as the Masi emerged in India. The Indian created this ink from the charred bones and tar. ठीक आहे, तर हाडापासून आणि जे कोळसा आहे याच्यापासून हे इंक बनवलेलं आहे आणि त्याचं नाव होतं मसी. And this is commonly known today as the India ink. ठीक है, it is a popular ink still today in India, China, Japan, as well as with artists who find that the bright colors and performance of the ink makes it enjoyable and practical to use. So this is the quality of the India ink. Okay, you want the manufacturing process, how ink is made. Here it is. Okay, जसं आपण डिस्कस केलं त्या पद्धतीनेच आहे. So first you have to add all this material in a suitable composition, then mix well, then you will get the paste of that all the materials, and then you can add the solvent or you can add the water. Okay, so make sure the surface tension is below the 49 per centimeter, so it can flow free from the nib of the pen. Okay, this is the process, and this is the one video. It can be easily available. You can get from the YouTube. Okay, जास्त काय डिटेल्स नाही त्यांनी दाखवलेलं नाही, फक्त शेवटचा पार्ट दाखवलेला आहे. त्यामुळे इथं आपण व्हिडिओ नुसतं तुम्ही बघू शकता इमेज. Okay, so this way you can prepare the ink either for the writing or for the drawing the pictures or for the printing. Printing साठी सुद्धा आपण इंक बनवावं लागतो. So you can prepare. So this is about the fountain pen ink. ठीक आहे, त्याच्यानंतर आपल्याला माहित असेल बॉल पेन आलेला आहे. आपण आजकाल सगळ्यांच्याकडे बॉल पेन असतं. बॉल पेन मध्ये पण आपल्याला रिफिल असते, त्याच्यामध्ये पण आपण शाई भरतो, इंक भरतो. ओके, तर ह्या स्लाइड्स मध्ये तुम्हाला ह्याच्यामध्ये बॉल पेनचं ओरिजिन मिळेल. ओके, so the first ball pen was invented in 1888 by the American leather tanner named John Loud, and it would take almost 60 years of attempts for the pen to catch on and become popular. जवळपास 60 वर्ष त्याच्यावर काम केल्यानंतर त्याला तेवढी पॉप्युलरिटी मिळालेली आहे. and nowadays you can see that everyone using this ball pen. Okay, जे इंक कंपोनंट आहे ते जवळपास सेमच आहे, कारण पण दिस इज द नाव सेम materials. The average ballpoint pen ink is composed of dyes and pigment particles. Carbon blacks for black pen, fusion for the red, or suspended cocktail of Persian blue, or crystal violet. So you can vary the color by changing the particular compound. जर रेड कलर पाहिजे तर कुठलाही काय वापरावं लागेल ते माहित पाहिजे. ओके, पर्शियन ब्ल्यू पाहिजे असेल तर तुम्हाला कुठलं मटेरियल किंवा कुठलं कंपाऊंड वापरावं, कुठलं डाय वापरावं ते माहित पाहिजे. Crystal violet is there, so you can change the color. Okay, and you need to suspend this compound or dye in a solvent of oil or water. Okay, the most common of the oil are benzyl alcohol or inoxyethanol. which mix with the pigment or dyes to create a smooth, vibrant ink that dries quickly. Okay, so this is about the ball pen ink. आता त्यात तुम्हाला ऑइल किंवा वॉटर इथं तुम्ही वापरू शकता. ठीक आहे. So this is about the ink. Okay. जर याच्यावर तुम्हाला काही अडचण असेल तर you can ask. Okay. So this is about the small scale industry of fountain pen ink and the silica crucible carbide. सिलिका क्रुसिबल कार्बाइड वर जास्त लक्ष असू द्या, त्याच्यात जास्त प्रश्न विचारण्यासारखे आहे. ठीक आहे. जर तुम्हाला काही अडचण असेल तर तुम्ही विचारू शकता किंवा मला मेसेज करू शकता. ओके. So we will stop here. Next time we have only one point is left. We will discuss that point. Okay. Thank you.